All right, welcome to Module 3. In this module, we'll talk about area and volume. It is a much shorter module than Modules 1 and 2, and so we'll probably cover Modules 3 and 4, both in the third quarter. So today's lesson is an introduction to area. I know you have found area and you've used area ever since elementary school, but hopefully we'll talk about it in a way that will deepen your understanding of what area is. There are no CCRSM standards directly tied to these two lessons, but I feel like these lessons will prepare you for some of our other discussions about area as we get into this unit. So we're starting with lessons 1 and 2. Let's get started. Lesson 1 starts off with a question: what is area? Now again, I know you have found area, you've computed the area of a shape, and you've used area before, but what is the definition of area? Well, informally, we might say it's the amount of space inside of an object. Now this definition is good, but it's not as precise as we need it to be. Okay, perhaps more precisely, it is the number of 1 unit by 1 unit squares that fit inside an object. Okay, now that is a better definition, a more precise definition, but still, let's define the word object. Okay, would it make sense for that to be like a baseball, a three-dimensional object? Well, no, area is used for flat objects or two-dimensional objects. So the definition we'll stick with is the number of 1 unit by 1 unit squares that fit inside a two-dimensional object. Now let me also point out that it's okay to have part of a square. So you can have like 0.32 of a square, and that's okay. Okay, it's not just whole number of squares. So down here's a question I'm sure you're familiar with. What is the area of the rectangle below whose side lengths measure 3 units by 5 units? And you might say to yourself, I know that the area of a rectangle is base times height. And the base looks like it's 5, and the height looks like it's 3. And so 5 times 3, because it's a rectangle, is 15. Okay, and that's true. But 15 what? Well, it's 15 square units. If you think about this, let's see, we have square units that are 1 by 1. If you think about 1 by 1 squares, you have 5 groups of 3, or 15 square units. So units squared, or square units. In Exploratory Challenge 2, we are asked to find the area of this rectangle who has side length measures √3 by √2. Now we can, again, count the number of square units inside this, but as you begin to count, we run into problems right here where we don't have a full square like we did in the last problem. So one option is that we can count, a lower bound, meaning I know that it's more than this number, and this rectangle is, the area is base times height. It's a rectangle, 1.6 times 1.4, which is 2.24 square units. So I know that it's more than 2.24 square units, but I know that it's less than, let's go out here to 1.8, and then I'm going to actually cut this off at 1.5. I know that's less than this blue rectangle, and the blue rectangle is still base times height, which is 1.8 times 1.5, which is 2.7 units squared. So we can think about this with a lower bound and an upper bound where we know it's more than 2.24 square units, but it's less than 2.7 square units. Now, one way we can be more precise about finding the area of this rectangle is by using a smaller grid. So instead of using by 0.2s, going by 0.1s, or maybe by a half, 0.05s, smaller squares will allow us to be more precise. Okay, and that will lead us into some thinking later on. Now, before we move on from this problem, the area for this is base times height. The base is root 3, and the height is root 2, which is root 6, and the decimal approximation of root 6 is 2.449 square units. So it is, in between, our lower bound and our upper bound that we found before. Next, we'll look at the area of this shape. Now, you probably don't know how to find the area of an ellipse or an oval. I'm sure you could Google it, but let's use the tools we just developed with the previous problem and look at what the lower bound and the upper bound might look like for this shape. Okay, I will begin to draw in some, triangles or rectangles to help me figure out what a lower bound might look like, and then an upper bound, and I know that it's somewhere in between there. So if I start drawing in some triangles, then I get some shapes that I know how to find the area of. Okay, so this shape in here is 5, and so is this one, and so is this one, and so is this one. So right here in this, this part, I have already 20. And then I have 1 here. If I put those together, I have a whole square. 2, 3, 4 from those triangles. And these two put together, if you put that together over here, it would feel like it's 3 full units. So with these together, I have 3, and these two together, I have 3. And so in total, I have 30 square units is my lower bound. Now we'll do the exact same thing, but do it on the outside of the shape to find an upper bound for this area. Okay, in this main section, I have 1, 2, 3, 4, 5, 6 by 1, 2, 3, 4, 5, 6. So this right here is a 6 by 6 square, which is 36. And over here I have 4 plus 4. And then over here I have, if I put this and this together, I have 1, 2, 3, 4 more. And put these two together, I have 4 more squares. So in total, I have 52 square units. And so that still is pretty broad. It's somewhere in between 30 square units and 52 square units. So how could we be more precise? Well, we could draw our grids even smaller. Okay, and that's how we become more precise with looking at this area approach using grids. Now, the reason I talk about this is because these ideas about cutting up areas into smaller pieces is fundamental to understanding calculus. So those of you who are heading towards calculus, think through how you cut up areas into smaller and smaller pieces is useful for you in preparing for calculus. In lesson 2, we look at some properties of area. One of them, we'll start with talking about congruent triangles. Well, we know that the area of a triangle is 1/2 base times height. Okay, we can use that. And so if you find the area of one triangle where the base is 12.6 and the height is 8.4, then we get an area of 52.92, I don't have any units, square units, meaning that if I cut this up into 1 by 1 unit squares, then almost 53 of them will fit inside this triangle. Exactly 52.92 would fit inside this triangle. Now this triangle over here is congruent to it by the side angle side congruence criteria, and so without computing it, then I would know I have the exact same area as this one. Okay, part B, circle the transformations that, if applied to the first triangle, would always result in a new triangle with the same area. Well, it has to do with the ones that are rigid motions, and translations are rigid motions, and rotations are rigid motions, and reflections are rigid motions. Dilations would not. They would change the area And the next lesson, lesson 3, talks about dilations, but that is not aligned with our standards, and so we're going to skip that one. But just so you know, rigid motions will preserve areas and distances and angles. The next figure we'll look at is this one, and we're finding the area that's shaded, and there are several, shapes put together, but you can find the area of each one and add them up. Okay, they're non-overlapping areas, and so this one right here is a triangle, and the area of a triangle is 1/2 base times height. The base and the height must be perpendicular. So this base right here is 3, and the height is 3. And so I get 1/2 of 3 times 3, which is 4.5 square units. This down here is a rectangle. Use a different color. This right here is a rectangle, which is base times height, which has a base of 7 and a height of 3, which is 21 square units. And this over here is the exact same as the first, with a base of 3 and a height of 3. And so the area is, again, 1/2 base times height. The base is 3, and the height is 3. So I get 4.5 again. If I add up 4.5 and 4.5, I get 9, plus 21. If I add these all up, then I get 30 square units. During class, we'll practice a lot more of finding areas, but that's enough for right now. Introduction to area. We talked about the definition of area is the number of 1 unit by 1 unit squares that fit inside a two-dimensional object. We talked about how to find the area of curved shapes by, well, at least an estimate for that using the lower bounds and upper bounds inside and outside of a figure. And we also looked about finding the area of composite shapes by finding the areas of the individual pieces and adding them together. And that is our introduction to area. Thank you for watching.